Hello everyone, we are the Mr. Coffee machine from section A13 and we are going to talk about our design project and what have done in the past weeks. And my name is Lucas.
I'm Tom.
And I'm Eduardo. All right, so this is our process flow diagram for our project. So as you can see here, we use the Mr. Drip Coffee Brewer, and we start off with 120 grams of under screen coffee beans, and we essentially roasted them to about a medium roast. And you can see all the streams coming out of the filter, the chaff, and then the volatile organic compounds. And from those roasted coffee beans, we used about 65.6 grams that we grinded. And from there, we essentially use the Mr. Coffee machine to put in the cool water and the grounded coffee beans, and we let it run. And essentially, in the end, our streams were the moist grounds, the volatile organic compounds, and our freshly brewed coffee of 927 grams.
Okay, so here's the mass balance of our final design brew. We started with 985 grams of water. After brewing, 927 grams ended up in the final coffee, and the remaining water was retained in the spent ground. For the coffee solids, we used 65.6 grams of roasted beans based on our TDS of 1.21%. About 11.2 grams of solids were extracted into the brew, while the rest stayed in the ground. This shows that our mass inputs and outputs close properly, firmly the consistency of our brewing process. And for the roasting portion, we used a Honduras roast with an energy consumption of 0.24 kilowatt hours. Dividing this by the roasted mass gives an energy intensity of about 0.00246 kilowatt per hours per gram of the roasted beans. Since our final brew used 65.6 grams of coffee, the total roasting energy attributed to the brew is around 0.161 kilowatt hours. This calculation shows that roasting is one of the main contributors to total energy usage. So improving roast efficiency is an important factor in minimizing overall process energy.
Okay, I'm gonna talk about the energy usage for each step. Like the what Tom said, like in the roasting, we use like 0.24 kilowatt hour to roast 100 grams of green beans, and we end up with 97.6 gram of roasted bean. So the energy per gram roasted bean is 0.00246. And moving on to the grinding, the energy used for grinding was less than 0.01 kilowatt hour, which is negligible and can be omitted from the analysis. So what I read up in the table is just zero. And the last step is the brewing. We used the Mr. Coffee machine as our brewing method. In total, we heated 985 grams of water, which required only 0.13 kilowatt hour of energy. And this section, I'm going to talk about the total dissolved solid and percent extraction. The coffee brew we made during the competition had a TDS of 1.21 and a PE value of 17.06. So considering the TDS, PE, and the brew ratio 15 to 1 that we used, the coffee feeds with a range of classic well-balanced extraction is the classic standard that you can see on the top right graphs. And moving on to the sensory evaluation. During the blind test, we gave our group an overall average score. Like you can see, it's only 21. The coffee showed acceptable balance, aftertaste, and the body, but its fragrance, acidity, and flavor was slightly below the average. However, we still won the third place with a taste score of 23.33. The overall coffee brew had a nutty fragrance with a moderate mouthfeel, a moderate bitterness, and a slight of sourness.
So what would we do better in a future competition? Well, there are a few things we would do better if we were to enter one. First of all, in the beginning of the competition, we did forget to record the energy usage of our roasted beans. So in the future, we'll make sure that we have everything accounted for, so we have enough time to finish the brew. On a second note, our flavor balance could also be improved even further from what it was by tweaking the grind size in order to bring the extraction towards like 18 to 22%, which is the sweet spot. Lastly, by increasing the value of our brew ratio, we can attempt to produce a sweeter brew while still keeping the desired mouthfeel and body. We'll use TDS and taste to determine where we are on the control chart to try to aim to that classic brew that everyone desires.